Hello, Seahawks. Today we're going to talk about solving one-step equation notes. I sometimes call them baby one-step equations because they're pretty simple. This is where we're going to start. And just so you know, almost all of these, many of these, you may be able to just answer in your head without showing any work. I am telling you now, you are not able to not show any work. You must show every single step. Okay? So, the first thing for you to know is that in order to solve an equation, you will have to do what is called the inverse operation. You're undoing the operation, okay? Normally, you have a problem, let's say, that says negative 6 plus 4, and you would solve that, and you would get your answer, which is negative 2, right? Okay, in this case, you're given problems, and if you look even at your first example there, where the number in the problem is missing, but you're given what the answer is equal, okay? So you need to solve the problem. So you are undoing the problem to get the missing variable, which most cases is x, but could be used, any letter could be used as a variable. Okay, in order to do that, you need to use the inverse operation to undo the problem, to undo the operation. So let's just talk about inverse operations, okay? The inverse of addition is subtraction. It's the opposite, basically. The opposite of addition is subtraction. So if you have an addition in your problem, to get rid of it, you are going to subtract. The inverse of subtraction is addition. So if you have a subtraction in your problem, you're going to add to solve it. The inverse of multiplication is division. So if you have a problem with multiplication, you're going to divide to solve it. And the inverse of division is multiplication. So if you have a problem with division, to solve it, you're going to multiply. Okay, let's give some of these a try. Okay, your first example is x plus 4 equals negative 9. And I like to rewrite the problem when we're first starting these. And part of the reason is because I like to keep my original problem nice and clean so I could see it. Okay, and then I go back and check them, which you'll see. So looking at this problem, I need to get rid of, and I'm going to mark this problem up, just like Mr. Cooper says to mark up the text. I'm going to mark this problem up. I need to get rid of the x plus 4. I'm sorry, I need to get rid of the plus 4. The goal for solving an equation is to get your variable all by itself on one side of the equation. So here's your equal sign, okay? And you want to get x by itself. Well, in order to get x by itself, you need to get rid of that plus 4, okay? Well, we already talked about the inverse operation, and if you look up ahead, up above on your paper, the inverse of addition is subtraction. So in order to get rid of a plus 4, I am going to subtract 4. I'm actually going to erase that line there because it kind of looks like division. But I just wanted to show what we were trying to get rid of. Okay, in order to get rid of the plus 4, we're going to subtract 4. And if you have a different colored pen, I would try to use a different colored pen like I am for this to show what you're doing to the problem. Okay, whenever you're solving equations, whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. Okay, and I put this little dotted line here just to make it clear which side is which. Okay, well, what is a positive 4 and a negative 4? Plus 4 minus 4 would be a 0. So I wouldn't write x plus 0. I call that it cancels out. It's no longer there. Okay, from there, I just bring down my x, because that's all that's left on my left-hand side. And then on the right-hand side, I'm going to do negative 9 minus 4. You have to remember your integer rules all the way back from September. Okay, I have a negative 9 minus 4. 9 is negative and 4 is negative. So I have same signs. Add. 9 plus 4 is 13. And it's a negative 13 because 9 is the larger number. Going back to those integer rules. There's your answer. Okay, now I just call, I have what I call a check. Okay, and I'm going to plug in the negative 13 for x. So where my x is in my problem, looking at your original problem, I'm going to plug in negative 13. So negative 13 plus 4. And I'm going to solve that part of the equation. When I solve that, I should get negative 9. Let's see. Negative 13 plus 4. I have different signs subtract. 13 minus 4 is 9, and it would be negative because 13 is the larger number. When I look, my negative 9 and my negative 9 is the answer, so my check works. Okay? Now, you may say to me, I could have figured that out in my head. Why do I need to show all these steps? Because these are baby one-step equations. They're nice and easy. As we move on to two steps and multi-steps, you need to show your work just like I am on this problem, but for the longer problems. So it's very important that you get into the habit of showing the undoing of addition and the undoing of subtraction and the undoing of multiplication and the undoing of division exactly the way I am on these baby one-step equations. Okay? When you're a baby, you don't just start running. You start crawling, and some babies start with like an army crawl where they don't even use their legs, and then they eventually go to their knees, and then they eventually stand up and hold on to things. So you do it step by step. Babies don't just get up and start running. Same thing here. We're going to go step by step. We're going to learn on a one-step equation, and then we'll move on to the harder problems. Very, very important. You write everything that I write on your notes today. If you have a different color pen, that's great to show what you undid, I don't even know if that's a word, on the problem. Do that. If not, it's not a big deal. Okay, let's try number 2. Number 2, I have x minus 5 equals negative 12. I'm going to copy the problem, keeping my original problem nice and clean. Okay? In order to get x all by itself, that's my goal when I'm solving an equation. I want to get rid of the minus 5. Okay? What's the opposite of subtraction? Addition. So in order to get rid of the subtraction minus 5, I'm going to add 5. Whatever I do to one side of the problem, I have to do to the other. Okay? Looking at the left-hand side of the problem, negative 5 plus 5 cancels out. That's 0. So I'm left with x on the left equals, and then I have a negative 12 plus 5. I have different signs subtract. My answer is 7, and it's a negative 7 because 12 is the larger number. Okay, I'm just going to do a check on this, plugging in negative 7 for my x. Negative 7 minus 5, I have same signs. I'm going to add. 7 plus 5 is 12, and that would be a negative 12 because 7 is the larger number. Does my answer check out there? I have a negative 12 and a negative 12. I'm good. Okay, again, showing all your steps, even your check. That should all be written down on your paper. Try number 3. Okay, number 3, I have x plus 12 equals 8. Okay, in order to get x all by itself, I need to get rid of the plus 12. The opposite of addition is subtraction, so in order to get rid of the add 12, or this plus 12, I'm going to subtract 12. Whatever I do to one side of the equation, I have to do to the other. Okay? Positive 12, plus 12 minus 12 is 0. That cancels out. I'm left with x on the left-hand side of the equation. Bring down my equal sign. Then I have 8 minus 12. Do I have same signs or different? Different signs subtract. 12 minus 8 is 4, and that would be a negative 4 because 12 is the larger number. Okay, let's do a check on this. I have negative 4 plus 12. Plug in my negative 4 where the x is. I have different signs, negative 4 and a positive 12. Different signs subtract. 12 minus 4 is a positive 8. 12 is the larger number, and that works out. Good. Okay, number 4, I have x minus 7. Oops. X minus 7 equals negative 14. I want to get x all by itself. In order to get x by itself, I need to get rid of the minus 7. The opposite of subtraction is addition, so I'm going to add 7. Whatever I do to one side of the equation, I have to do to the other. Negative 7 plus 7 cancels out. I'm left with x on the left-hand side. Bring down my equals. Negative 14 plus 7. I have different signs subtract. 14 minus 7 is 7. And that would be a negative 7 because 14 is my larger number. You have to go through your rules for every single one. Okay, let's do a check on that. Plugging in negative 7 for x, so I have negative 7 minus 7. Do I have same signs or different? Negative 7, same signs. Add 7 plus 7 is 14, and it would be a negative 14, and that works out. Okay, I would maybe pause right now if you want and try 5 and 6 on your own, or you could just continue with the video. On number 5, I have a 12 plus x equals negative 15. Okay, in order to get x all by itself, I need to get rid of that 12. Okay, well, that's a positive 12. Now, this one was a little tricky. Hopefully, if you tried it out on your own, you figure it out. In order to get rid of that positive 12, I need to subtract 12. Figure out how you're going to get 0 there. So a positive 12 minus 12. Whatever I do to one side of the equation, I do to the other. Notice I do that right away before I do anything else, because I don't want to forget to do it on both sides of the equation. When you have 2 or 3 step problems, multi-step equation solving, you don't want to forget. Okay, over here on the left side, positive 12 minus 12, that would be 0. That cancels out. You're left with an x equals negative 15 minus 12. I have a negative and a negative, same signs. Add 27, and that would be a negative 27 because 15 is the larger number. Okay, let's check it. We have 12 plus negative 27. I have different signs subtract. 7 minus 2 is 5, 2 minus 1 is 1, and that would be a negative because 27 is the larger number. That checks out. We're good. Okay, maybe if you didn't pause for number 5, pause now for number 6. Number 6, we have negative 13 plus x equals negative 9. In order to solve the problem, we need to get x all by itself. In order to get x by itself, I need to get rid of this negative 13 or minus 13. The opposite of a minus or a negative would be a positive or an add 13. Whatever I do to one side of the equation, you have to do to the other. Negative 13 plus 13 cancels out. I'm left with x on the left side. Bring down my equal. Negative 9 plus 13, I have different signs subtract. 13 minus 9 is 4, and that would be a positive 4 because 13 is the larger number. Okay, let's check that. Plugging in 4 for x, we have negative 13 plus 4. I have different signs subtract. 13 minus 4 is 9, and that should be a negative 9 because 13 is the larger number. That works. Okay, now we're going to move on to multiplication and division in the equation. We have 2x equals negative 28. Okay, when you have a number next to a variable like that, that means to multiply 2 times x. So the inverse of multiplication, the opposite of multiplication would be division. So to solve this problem, we need to divide. In order to get x by itself, we need to get rid of that 2. So we're going to divide by negative 2. Look what it looks like. We're not using this division sign anymore. Okay, that's elementary. This is showing division when we write it as a fraction. This means 2x divided by 2. This is how you need to show it. Okay, whatever you do to one side of the equation, you do to the other. I want to make this very clear. I do not want to see the division symbol like this anymore. Okay, you're now showing it as a fraction like that. Okay, well, 2 divided by 2 would be 1. Okay, this would be like a 1x, but we don't write 1x. There's an invisible 1 in front of the x, right? So we're just going to write that as 4x equals, and then on the right hand side we have negative 28 divided by 2. We're changing to multiplication. I have an 1 negative. 1 is odd, so my answer is going to be negative, and 28 divided by 2 is 14. My answer is 14. Negative 14, I'm sorry. Let's check that. 2 times negative 14. And don't forget, we're not using the x anymore for multiplication either. I put this in parentheses to show it. I could do the dot for it if I wanted to. That's fine, okay? 2 times negative 14, I have 1 negative, so my answer is negative, and 2 times 14 is 28. Checks out. We're good. Why don't you give number 8 a try, but be very careful if you're sure of yourself. Number 8, we have negative 4x equals 16. Okay? We want to get x all by itself. In order to get x all by itself, we need to get rid of the negative 4. However, this operation, again, is multiplication. Okay? The inverse of multiplication is division. So in order to get rid of that negative 4, I'm going to divide. Okay? I'm going to divide by a negative 4. Okay? It's very important that you divide by a negative 4. Because if I divide by a positive 4, that would actually give me a negative 1. You don't want a negative 1x, you want a positive 1x. So if I divide negative 4 divided by negative 4, I get a positive 1. Okay? So, going back to my problem, whatever you do to one side of the equation, you have to do to the other. Okay? Negative 4x divided by negative 4 cancels out. Now, it's not 0, it's actually 1x, but you don't write 1x, you just write x. Bring down your equal sign, and then I have 16 divided by negative 4. I have 1 negative, so my answer is negative, and 16 divided by 4 is 4. My answer is x equals negative 4. Okay, and let's just check that. Negative 4 times negative 4. I have 2 negatives. My answer is positive. 4 times 4 is 16, and that works. That checks out. Okay, on the last one, I have x divided by 7 equals 133. Okay, in this problem, again, I need to get x all by itself. In order to get x by itself, I need to get rid of the 7. Okay, well, this is division. So the inverse of division is multiplication. So in order to get rid of the divide by 7, I'm going to multiply by 7. Look very closely at how you should be showing your work. I can put 7 over 1, and now it kind of makes sense how the 7's cancel each other out, doesn't it? Okay, if I had 7, let's say times 1/7 here, okay, I could put this 7 over 1, and I would cancel out my 7's to get 1, and that would equal 1, right? Okay, same thing here. You're going to multiply by 7. I'm putting that 7 over 1 so you could see how my 7's cross-cancel out. And that gives me 1x. Okay, again, whatever you do to one side, you have to do to the other. Okay, so on the left-hand side, I'm left with 1x, but we don't write 1x, we write x. And make sure it's a positive 1x, and in this case it is. On the right-hand side, 133 times 7. That might be something you would want to do on your paper, but 7 times 3, if you wanted to do it, you can. I don't want to take up space. 7 times 3 is 21. 3 times 7 is 21. That's plus 2 is 23. And 7 times 1 is 7, plus 2 is 9. So 931. That one was a big number. I'm not really sure what I was thinking there. And we're going to check that by doing 931 divided by 7, okay? And on this one, we'll do some long division. 7 goes into 9 once. That's 7. That's 23. That would be a 3. That's a 21. That would be 21, and that would be 3. I get 133, which checks out. We're good. Okay, and then we have our last problem. Okay, we have x over 4 equals negative 7. In order to get x all by itself, we need to get rid of the 4. Well, x divided by 4, that's division. The inverse would be multiplication. So I'm going to multiply by 4. Whatever I do on one side, I have to do on the other. Okay, and again, make sure you're showing your multiplication like this. 4, my 4's cross cancel out. I'm left with 1x, or just x, equals negative 7 times 4. I have 1 negative. My answer is negative. 7 times 4 is 28. Okay, let's do my check. Negative 28 divided by 4. I have 1 negative. My answer is negative. 28 divided by 4 is 7, and that works out. Okay, and again, I understand that some of these you may be able to do in your head, but you are not going to. You're going to show every step. If you don't show your steps, you're not getting credit. Have a great night, and we'll see if there's a Ryan show. Hold tight.
It's the famous one and only Ryan! There. Okay, today I'm going to show you how to do a blueprint. I don't know how, so let's just make it up. So we put that there, then we put that there, then we put that there, and how about,
What's your hands?
let's do that then. Let's do this.
Everybody's gifts. I'd be like, I didn't
What up?
donate it to the chef.
There, and this is my thing. Now, I need this kind of marker because we want a nice blueprint. And let's make instead a thing,
Excessive.
a blueprint that people make on trains. This is going to be called magic. Yep, I know you guys already know magic. I'm going to show you more magic. And this magic is big magic. Okay, so
You need to do math.
let's do apple. Let's do tomato soup. Let's do the tomato soup method. Tomato, 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 tomato. Tomato, tomato. I think there's chicken broth in tomato soup. I'm not sure. Here's our tomato soup. Now let's use it. Now here's our spoon. I'm gonna run all night. Okay, scoop. You eat tomato soup. Yum, yum, you say. And then
Move
you
on.
thank.
Move on with the tomato soup.
Then you thank your mom for making it. Now, the tomato soup method is when you count how many tomatoes. Let's count. So you ready? 1, 2, 3, 4, 5.
Looks like Ryan doesn't know how to count.
Now let's add the broth. Let me put the shaker out. Now let's add the broth. There we go. Now let's add the broth. Here's our shaker. Broth come out. No, there we go. Now the broth. Doo-doo. Whoosh! See how the broth goes in, Mommy? Ready? I'm going to pour some broth. There we go. Now let's do this. Change this color to this color.
How about some milk?
I just did some math. Tomato soup.
Big division.
Now let's do some
Quick
division.
Oh.
I don't know what problem to do.
55,400.
Let's do 5,400
Divided by
divided by
6.
6. Okay, so first you would do 54 divided by 6, which is 9. Add the zeros, 900. That's what it equals. Now back to the fun.
That's fun.
So 5,400 divided by 6 equals 900. Okay, now let's get back to our tomato soup
Okay,
method.
and then wrap it up.
Then I'll have to wrap it up. Because Mrs. Sicoli, is that what you guys call her, is making me. You ready? Here's my decoration for you guys. For being such good kids. No, the country that I am in school is Japan. So now let me make the Japan flag, even though I don't know what it looks like.
You read that? You're saying it's not a lot.
Let's do.
But it's really saying it's not a lot for some people, but it's a lot for his school because it's such a small school.
Okay, so.
And I mean,
Nope.
I tell you, like, he handles it fine. They were all working, you know.
Nope, I can't do this with that. So we need to use this.
Okay, wrap it up.
Here we go. There's the fake Japan flag that I don't know how to draw.
These three.
Nope. Okay, now what we do is take this little thing, make it red, and go whoosh, whoosh, whoosh. Japan flag! Woo! Everybody clap. Or I think that's China.
Well, I don't know if it's anything,
I
but
think you're supposed to make it rain.
Okay, I'll make it rain. Time to make it rain. Woo, it's raining! Woo, oh no, it's raining! And we're out.
Peace out, yo.